Okay, so we are going to graph, or we're going to find the area between the curves y equals sine of x and y equals cos of x from x equals 0 to x equals pi over 2. So the first thing that we want to do is to draw the graphs, and we know what the graphs, the graph of sine of x looks like, at least on one period from 0 to 2 pi. Let's do it in red, right? It looks like this, right? That's our y equals sine of x. And, right, so that is from 0 to 2 pi. So really we only care about this portion here, which is between 0 and pi over 2. So let's draw a cosine, right? Starts up here, looks like that, right? Goes down to -1 at pi, back up to 0, and then up 3 pi over 2, and then up to 2 pi, or up to 1 at 2 pi. So that's our cos x. Right, and so really we see that we have this kind of separation of the region as two regions, right? So this maybe we could call region 1, and then this we'll call region 2. Right, so we see that on region 1 we have that the top curve is cosine, and then on region 2 the top curve is sine. So let's just draw this portion that we actually care about here. So looks like that, and then like that. Right, so we have what are we calling this? Region 1. And this is our region 2. So we have that on region 1, we're going from x equals 0 to x equals pi over 4, because that's where sine x is equal to cos x, right, at x equals pi over 4. And on that portion of the region, we have that the top function is cos x and the bottom function is sine x, right? And then on region 2, which goes from pi over 4 to pi over 2, we have that the top function is the red curve, right, which is sine x, and the bottom curve is cos x, the blue curve, right? So we can find the area of each of these regions and then just add them up, and we'll get the total area of the whole region, right? So our whole region we'll just call, R, right, is equal to the union of the region 1 and region 2. And so if we call A1 the area of region 1, then, and A2 the area of region 2, then the total area of, R is the area of the sum of the area of R1 and the area of R2. So sum of A1 and A2. Right, so we need to find our A1 and A2. Right, so we'll do that down here. We have A1 is equal to the integral from 0 to pi over 4 of yt minus yb. So that's cos x minus sine x dx. Right, the integral of cosine is sine x, and the integral of sine is negative cos x, right? And we're evaluating from 0 to pi over 4. Let's just draw a little line here so we can keep our work separate, each region, right? And we have evaluating this, first thing we could do is at least write this as sine x plus cos x, right? And now evaluating, we have sine of pi over 4 plus cos of pi over 4, right, minus sine of 0 plus cos of 0, right? Sine of pi over 4 and cos of pi over 4 are both square root 2 over 2. Sine of 0 is 0, and cosine of 0 is 1. So we get square root 2 minus 1, right? Okay, so now let's find the area of region 2, right? Sorry about that. So, right, so we have area of region 2 is equal to the integral from pi over 4 to pi over 2 of top function sine x minus bottom function cos x, integrating with respect to x. Integral of sine x is negative cos x. Integral of cos x is just sine x. And so we have evaluating for pi over 2 to pi over, or from pi over 4 to pi over 2. Okay, we have negative cos of pi over 2 minus sine of pi over 2 minus negative cos of pi over 4. It's a 4. Minus sine of pi over 4. All right, and cos of pi over 2 is 0. And sine of pi over 2 is 1. And then we're subtracting this quantity, negative cos pi over 4 minus sine pi over 4, which we know will be negative square root 2 over 2 minus square root 2 over 2, right? And that will be negative 1 minus negative square root 2, right? Which is negative 1 plus square root 2. Or we could just write this as square root 2 minus 1. So you see that these are actually the same. They have the same area, right? A1 and A2 are both square root 2 minus 1. So just as an observation, right, why is that? Well, just due to symmetry, right? Our trigonometric functions are very symmetric. And so really we could have, just knowing that, could have just found the area of one of these regions, for example, R1, right? So we could have just found A1 and then just multiplied by 2, right? But okay, so let's see, we have area then is equal to A1 plus A2, so that's square root of 2 minus 1 plus square root 2 minus 1 is 2 square root, sorry, it's a little messy here, is 2 square root 2 minus 2, right, or 2 times square root 2 minus 1, right? So that's our area. And just as a sanity check, you know, is the area positive? Well, square root of 2 is greater than 1, so yeah, that is going to be positive. So, okay.